All right, I think we are live now. Yes, so welcome to this tech talk, Mettle's journey towards throwaway clusters. 2 seconds, there we go. The agenda for today, you've probably seen the invitation and on Meetup or in Slack or whatever place you sort of found this invitation. Just a brief welcome by me. My name is Kasper. I run the Cloud Native Aarhus group with a couple of other guys that I'll show you in a minute. But I'm also running the sort of the broader Nordics thing, Cloud Native Nordics. So this is a Cloud Native Nordics event, but it's organized by the Cloud Native Aarhus organized team right now. And yeah, then afterwards we'll have Steve on talking about Mettle's journey towards throwaway clusters and some Q&A. And then thank you and hope to see you next time. So who is Cloud Native Aarhus? We are 4 guys. Mike, he's on the call. Rasmus is also on the call. Henrik is having some trouble getting into this call, but so he'll probably watch from the sidelines. And then it's me. So Mike is an infrastructure engineer at Humio. You can find him on Twitter. Rasmus is a CEO who codes, apparently. That's also a thing. And I'm working as a site reliability engineer at a company called Luna. I have a lot of different roles, but yeah, site reliability engineer is probably the most saying one. I'm also a Cloud Native Computing Foundation ambassador and trying to spread the word around Cloud Native in the Nordics with one of these events. And then Henrik is a consultant at Pragma. You can also find him on Twitter if you like. So Cloud Native Nordics, we are a rather big meetup alliance. I think we are around 6,000 or 7,000 members in total across 13 different groups. Stavanger is missing on this map. Should update this. But yeah, we are a lot of people trying to help each other out and create awesome events. Now that Corona is here, we try to do a lot of stuff online as well and help out in that way also. So this is also one of these initiatives. Oh, sorry. We already have the next event planned, the next tech talk. It's introduction to GitOps and GitOps toolkit with Alexis Richardson and Stefan Prodin from WeWorks. It's going to be an interesting topic as well. We have been talking a lot about GitOps in the Slack community. So this is a good way for you to ask your questions also if you have any for the, I guess, founders of GitOps. And then lastly, for today's talk, if you have any questions during the talk for Steve, post them in the YouTube chat or go to Tech Talks on Cloud Native Nordic Slack and ask the questions. We will moderate the questions afterwards. And yeah, we'll have time for a Q&A as well. This video recording will also be available after this presentation. And today's speaker, we have Steve Wade. Steve currently leads the platform team at Mettle in London. He was a principal Kubernetes consultant at Apprenda, and that's actually when I met him back in, I think, Berlin, KubeCon or something like that over a couple of years. Been talking with him on and off for the past couple of years. He's very passionate about Cloud Native, and I'm looking very much forward to hear what he has to say today. So yeah, with that, I'll just hand this over to him. So I'll stop my screen share. And are you ready, Steve?
I'm ready. Can everyone hear me okay?
Yeah. Good.
Perfect.
And we see the screen. Yes.
Perfect. So I'm going to spend the next about 25 to 30 minutes talking you through the journey that we've been on at Mettle. So we've been on a bit of a GitOps journey. So I'm going to try and steal as much of the limelight from Alexis and Stefan as I can and let them do the technical deep dive in your next tech talk. So yeah, as Kasper said, my name's Steve Wade. You can find me on Twitter at Swade1987. I've been using kind of Kubernetes since 1.2, back when it didn't really work that well. It's come on leaps and bounds since then. I blog quite a lot as well on Medium, so a lot of the kind of deeper understanding of this topic area I have blogged about in different granularity. So check that out. So I want to start with this quote from Kelsey. So Kelsey said, once you found success, your next goal should be helping others to do the same. But I want to take success out and essentially replace it with a pattern that works. So at Mettle, we've been on this journey. We've found a pattern that works really well. And now today I'm going to try and share that with you and we can talk about the journey for us to get there. So a little bit about Mettle. So Mettle is a digital-only bank that allows business customers to create invoices, reconcile them, chase for payments, et cetera, et cetera. So it's totally digital. There's no kind of buildings. You can't walk into somewhere and get your pay your invoice. It's all done on your mobile phone or on your iPad or your tablet. So we run in the public cloud, we run in Amazon, and we'll go into that in a little bit more detail. And we kind of align on a set of principles. So our very, very top high-level principles are that we want to be open by default. We are open source by default as well, so we don't use any proprietary products. We try and use as many open source technologies as we possibly can. We align to the CNCF landscape as close as we possibly can as well from a longevity and governance perspective. And we are totally Kubernetes centric in terms of workload management. So as I said before, we run Kubernetes on Amazon. And we have a number of different environments. So we have the personal platform sandboxes. So that's kind of my own personal sandbox where I can test some stuff out and not break any of the other environments. Every platform engineer has one of them. And then we have a number of other environments. So we have a platform sandbox, which is for the platform team as a whole to kind of sandbox out ideas. So if we want to move to a new version of Istio, or we want to move to a new version of Prometheus, we use that environment, and we don't impact any of the other development-based environments. And then we have a set of other environments there that are for developer pipelines. So we've got dev, staging, and production. Bug bounty is where we have our own dedicated environment that looks like production, that is used for ethical hackers to try and hack us and find vulnerabilities in our software and our kind of stack. And then finally, we have the tools environment, and that's where the developers' CI/CD tooling lives. But we're destined for more, right? Developers are always like, well, Steve, you can cookie cutter and rubber stamp these environments out, in about 20 minutes. Can I have another environment because I need to do integration testing, or I need to do performance testing or stress testing? So we're destined to get more environments. It's a natural progression in the life cycle of Mettle. So we need a way that this doesn't become, such a laborious task, and we have a nice cookie cutter rubber stamp way of doing it. So the agenda for today, I'm going to give you a little bit of a history lesson about the platform pre myself and my team joining. So what was there before? What were some of the good things? What were some of the not so good things? And then the bulk of it is going to be around the journey that we've been on. So where did we start? What are the lessons that we learned? And then, as with every journey, it's not complete. So we're going to talk about what's left to do. And then, as Casper said, we're going to wrap up with a Q&A at the end, so you can ask me all the questions. So a little look back at Mettle's existing platform. So to start with, it was very ticket driven. And I want to kind of start with the people problems more than the technology, because the technology is easy, right? The difficult bit is the people and the culture. So it's very ticket driven. So you as an engineer would submit a ticket to our backlog. As anyone that works in platform engineering knows, that a developer's ticket probably isn't that important. You're too busy doing something else. And then within a week or so, they would come and chase you and say, why have you not worked on my ticket? It's been in your backlog for a week. I can't release my change. So there's this natural friction, right, between the platform engineering team and the developers. And we're stopping the developers from being able to innovate and move forward. Then we come onto the platform, and the platform that we inherited looked a bit like this. It was like playing a game of Jenga, right? So you'd pull this tiny piece out, or you'd push this tiny piece into the development environment, and it was fine. And then you do it to staging. But then by the time you get to production, it kind of looked like this. And the reason why was because, for cost saving reasons, the development and staging environment ran in the same VPC and the same account in Amazon, and was sharing load balancers, and it was all a bit of a mess. And then production looked totally different. So we had this kind of apples and oranges problem. So all the changes that we made in downstream environments, by the time we made them to production, we didn't really have any confidence that they were going to work. We ended up having numerous outages in production because the changes that we thought were going to work never worked. It was just all a bit of a mess. And then this happened, right? So I'm having to sit in front of the executives at Mettle and convince them that they are paying a contractor to come in and help them. And what I'm not doing is I'm not helping them at all. I'm actually making it worse because we're getting more incidents. This is not a good place to be for anybody, and we needed to fix this, right? I want to be the other side of this table. I don't want to be the person that's getting questioned. I want to be questioning someone else. So confidence is contagious, but so is the lack of confidence, right? And with this current structure, everyone had a lack of confidence in the platform team, right? Everyone blames the platform for everything. So my application didn't deploy. Oh, well, that must be the platform. Or, you know, I'm trying to browse to this this URL, or I'm trying to access this feature on my phone. It's not working. Well, it's naturally going to be the platform. So we ended up doing this, right? It was essentially a tug of war. We've got the platform team out of shot, and then the whole of the Mettle organization in this picture pulling in the totally different direction. So we were essentially sticking a load of rubber stamps on a platform that wasn't fit for purpose. So then we come on to Concourse. So Concourse is what the developers use to deploy. So we deployed between environments a little bit like this. So you would do a Helm upgrade. They were leveraging Helm for all of their applications. We still leverage Helm today. And you just pass in the environment values that you wanted. So that was the way that we deployed to every environment. But there's a problem with that, right? So we've essentially activated God mode. So Concourse has essentially got privileges to be able to deploy absolutely everything to every single environment. So when you're a bank and you're highly regulated and you get people coming in and trying to hack you from the inside, playing the rogue employee scenario, the first place they went naturally is that Concourse box, and they found all the goodies. Right, doesn't really look very good. We needed to kind of reset and think about having a different approach to this. So we hit the reset button. We're going to park all of the kind of stuff that didn't really work, and now we're going to tackle a complete rebuild of the way that we kind of leverage Kubernetes and kind of bring it up. So we started with a set of principles, and I think the first most important principle is we wanted out the gate to make this a self-service platform. So that tug of war needs to stop now, right? We all need to be around the same table, and we all need to be eating at the same time. The platform engineering team focus on the platform and making that stable and bringing new features to that. And the developers have the freedom and the ability to keep innovating and giving new features to our customers. So both sides start to win. So then we started with a mission statement. So this was a mission statement that I presented back to the executive board and said, look, what we currently have is not really working. This is our reset. So we said we're going to provide an easily extensible, config-driven, ephemeral platform with clear ownership and, most importantly, reliable and consistent. So this has almost every buzzword that an executive wants to hear in one sentence. So they immediately bit at this and they said, Steve, this sounds great. Now you've got to deliver it. So the statement is there. Now comes the execution. So there's three main components that I want to talk through today of how we bring up clusters and how we use them within Mettle. So we're going to talk about Terraform and how we do version controlled infrastructure. We're going to talk about Flux around the GitOps model and how this provides us with this rise of the Phoenix style deployment and how we reconcile everything inside the cluster every time we bring up a new one. And then I'm going to touch a little bit on KubeBuilder because we built our own little custom operator. So let's start with easily extensible and config driven. So as we said before, we run in Amazon. On top of Amazon sits our custom Kubernetes cluster. And then all we need to do then, sounds a bit more simpler than what it is run the Mettle workloads, right? So conceptually, this is what we're going with. So infrastructure. So we've got a dedicated repository for all of our Terraform modules. So those modules are consumed by a number of other modules. So you get a little bit of inception there, or they can just be leveraged on their own. So we start from the bottom. So for those of you who are familiar with Amazon, that starts with the organization. And then inside the organization, we have accounts. And then inside the accounts, we have, you know, the kind of platform as a whole, all the VPCs, all the networking, all of the S3 buckets, etc. And we consume those modules based on specific hashes, right? And that allows us to make fine-grained changes and keeping the blast radius low. And then finally, after we've got those modules, every environment is built from a set of routes. And what I mean by routes is a number of modules that are executed at a specific hash. And the reason why we have different routes from roots, you can kind of switch roots for repositories. The reason why we have that is because different areas of the platform have different life cycles, right? I'm not going to do a Terraform destroy on the data root because, you know, I'm going to be Mark Zuckerberg again. But I may do that in Kubernetes because we want to spin up a new version of Kube and move across. So our kind of roots are split out in terms of their life cycle of execution. So here is Terraform modules, and inside that we have a number of different modules, all the way from the AMI that we use down to the specific sets of Kubernetes manifests. Then we have a root here that we can see. So we've got Terraform env-k8s, and that is our Kubernetes root for us to be able to deploy Kubernetes. So you can see there that we are referencing a specific hash of the Kubernetes module. We are passing in a set of information, and then at execution time, we are going to execute that Kubernetes module at that given hash. Two modules specifically that I want to highlight here are application IAM role and application S3. And those are really the modules that are leveraged by our application developers. So 9 times out of 10, they want to store something in an S3 bucket, and we need to create the IAM roles for them to be able to do that. So they leverage these two modules. And what we've done is this is the interface, right? So we've given them an interface for them to be able to create S3 buckets and be able to create IAM roles, and for them to be able to consume them within their applications. So then we have another module called Data EV. EV is a product within Mettle. We've got a number of products that we run, but this is specifically the data route for EV. And as you can see here, they consume the application S3 module. They pass in their application name, in this scenario being Bill's data. And then they create the corresponding IAM role. So we have this kind of one-to-one mapping whereby an application has an S3, may or may not have an S3 bucket, and the name of the IAM role needs to correspond back to the name of the microservice. So we have some CI here that makes sure that the app name that is listed in the IAM role is the same name as the file. So it gets us that consistency. So we've kind of touched a little bit there on easily extendable and config driven. We're driving all of the infrastructure changes via Terraform. We've made it extensible because we've got all those modules and they're all at different hashes, and we've got this fine-grained way of making changes. So the next step is, and the most important step for us, was how do we make these clusters ephemeral? So really it's all about GitOps, and that's kind of what the crux of this talk is going to be about. So for those of you who don't know what GitOps is, essentially you might be familiar with these kind of commands to make changes to your cluster. So you've got the kubectl apply -f. You could pass in a file there or a directory full of files, and that's going to submit those manifests to the Kubernetes API, and then those workloads are going to get deployed. Or you may have seen this one before. So for us to upgrade images, you may run kubectl set image. That's going to change the image that's currently specified from 1.1 and move it to 1.2. Or more than likely, you've seen this command, so the Helm upgrade command, which is taking your Helm release from V1 to V2. So essentially what we're doing is we're throwing that all in the bin, right? Because that's push-based. We want to be pull-based. We want to reconcile from the inside. And we want to do that by making changes, and those changes are going to be Git pushes, right? So we're going to be doing Git push or Git merge. So let's take a step back and actually look at the GitOps operator and how Flux works. So Flux does bidirectional syncing. On the left-hand side, you can see the cluster Git repository. That's where all of your normal YAML files will be. They could be Helm releases, they could be deployments, they could be RBAC configuration, whatever you want. So that's the left-hand side. Then at the bottom in the middle, we've got this reconcile loop that's happening on our image registry. So Flux has this ability to be able to poll and look for new image versions, upgrade those inside the Kubernetes cluster, and then write back to Git. So Git now becomes our audit trail. It's our history. It's the log of all changes that are happening to the cluster in real time. So this is a bit more of an exploded diagram, but essentially what I wanted to show here is if you look at the bottom left, no more kubectl apply, right? It's all being driven from configuration, whether we push changes into the Git repository or whether we retag images. So in the past, when we were talking about the old platform, we were leveraging Helm. That hasn't stopped, but what we're leveraging as well is Flux has a Helm operator. So the Helm operator allows you to be able to define these resources called Helm releases. So imagine a Helm release as a version of the chart that you want to deploy and the values that you want to override. So the same way before that you did a Helm upgrade, instead of doing that, we're going to declaratively declare what that looks like inside a YAML file. Inside the Kubernetes cluster sits the Helm operator, and now that is the thing that's responsible for doing the Helm upgrade or the Helm delete or the Helm install. So rather than us manually pushing changes into the cluster, the Helm operator is the thing that is responsible now for doing those Helm commands. So let's just take a quick look at a Helm release. So here's an example Helm release for sealed secrets. So, the main bulk of it is a release name. So important thing to note here, and a gotcha for anybody that's using this, is the release name needs to be unique at the cluster scope. So you can't have the same Helm release name being deployed to two different namespaces. It will actually end up clashing. And then the bulk of it really is the chart version. So you can specify the repository here, the name of the chart, and then finally the version that you want to use. And that's going to give you a nice fine-grained way of being able to make chart changes and roll them out slowly. Then the Helm operator has a number of annotations. So these annotations here are essentially saying, for this Helm release, I am going to allow you to automatically make changes to the image version that's currently being deployed. And I want you to target those using this semantic version. So if we deploy version 3.0.0, and then as part of our CI pipeline, we tag a new image of 3.0.1, Flux and the Helm operator is going to pick that up. It's going to deploy 3.0.1, and then finally it's going to write it back to Git and tell us that it's done it. So Flux secrets, we also use this as well. So this is using the Bitnami sealed secrets controller. The way this works is that publicly you can have a public key, and then privately inside the environment you have a private key. You seal existing Kubernetes secrets with your public key. They can obviously only be unsealed or decrypted by the private key that's running in the environment. That will deploy a sealed secret, and then the sealed secret controller will unseal that sealed secret, turn it into a secret that you're used to in Kubernetes, and you will move on. So what that's allowed us to be able to do is now have all of our configuration for all of our secrets in Git, right? So the important thing is GitOps, everything driven from Git, and we reconcile into the cluster, and then we make the changes. So there's two main repositories in terms of Kubernetes and manifests that I want to touch on today. So we've split this up so that we have the platform engineering workloads and then the Mettle workloads. So the platform engineering workloads contain everything that we need from a platform perspective. So they are all the namespaces, all the RBAC rules, all the ingress controllers, all the logging stack, all the monitoring stack, essentially everything that is required so that the developers can just consume the platform, right? That's the most important thing. They are consumers of the platform. All this stuff should be there out the box. They focus on deploying their applications. So that's the split. Then we have K8's releases Mettle, and that is the repository that contains all of the workloads or all of the declarative Helm releases for Mettle workloads to be able to be deployed. So let's take a closer look at what one of these looks like. So here is an example of the account balance Helm release in dev. So there's a couple of things to note here, really. We have a environment prefix, and this is extremely important in the way that all of this hangs together. So each environment has this 3-character prefix, so dev, dev, prod, prd. And this goes and flows all the way through our system, and this is how we reconcile everything. So all of the dev-specific Helm releases need to sit in the dev directory. And then what Flux is going to do in dev is it's going to look at this directory, crawl this directory, and then make a set of deployments from it. So dev here in the directory, and then a couple of devs listed inside the Helm release. So we are looking and we're allowing automated changes of this Helm release, and we're going to look for new image tags that start with dev-star against the repository, which is at the bottom. So in terms of image progression through environments, you're probably thinking, okay, I get a rough understanding of how Steve's going to get this to get deployed to staging, but we'll come on to that in a second. So we've got this structure now, right? So we've got this 3-character prefix, we put it in the directory, we put it in the tag that Flux is looking at, and then we have it as the tag of the first image that gets deployed. When Flux sees changes, so a developer has deployed a new version of the account balance, it patches the release locally inside its own Flux pod, applies that to Kubernetes, waits for it to be successful, and then writes that change back to Git. So now, like I was saying before, we have an audit trail. We have a list of all the changes that were made and when they were made. So from a compliance and audit perspective and regulatory perspective, if they ever come in and say, like, what change was made between 1 and 3 p.m. in production last Thursday, we have a way of being able to show that, right? We just show them these Git commits. As well as that, and what's quite powerful is when you have an incident, you also have the change log. These Git commits are the change log for all the changes that have ever been made. So if we saw, a change with, in this example, account balance, and we said it wasn't dev, it was actually production, the first place we go is we look here. We say, okay, we've seen an incident has occurred. Has a new version of this microservice been deployed? And rather than going to CI and going through all the pipelines and everything like that, we go to a centralized location and we just trawl the Git history. Then what we did is we copied and pasted this, right? So we got it working for one Helm release for one of their microservices. We could then get it working for all of their Helm releases for dev, and then we rinsed and repeated this for all of the environments. So how do we deploy changes through the environments now? So developers still use Concourse. They're still looking at their Git repository for their application. First thing we do is a Docker build, and then we tag that with a dev-commit SHA. So we're using the long commit SHA here as the differentiator, and I'm going to explain to you why we decided to do this. Then we do a Docker push. That goes to GCR, which is our container registry. And now we've got this new image with a new tag of dev-123. So now we've got that in GCR. Flux has come in and said, okay, well, now you've got a new image tag. I'm looking at my Helm release and I'm seeing that actually you've set automated to be true. So now I've got some work to do. So what that does is it patches the Helm release locally. So this is local to the pod, the Flux pod itself, right? It then does a kubectl apply of those changes to the Kubernetes cluster, and then finally commits those changes back to Git. So I want to pause here a second, and you're probably asking yourself, why, Steve, why did you do the long commit hash? So in the past, I used to be a CI/CD consultant, and I always used to say, use samver, right? Use 1.1.build number. The issue happens when you lose the database that's backing your CI, and then you start a new one. And then what's the 1.1.1 now? Is it the old build or is it the new build? With the commit hash, it's always unique, right? It's unique for that exact commit. So we can, the concourse pipeline is ephemeral as well. We can lose the data, we can stand the new one up, and we reconcile back to where we were, and we get brand new unique images every single time. Then Concourse has a wait. We have a small kubectl script that essentially uses that long commit SHA, is looking at the deployment and is looking at the corresponding replica set, make sure that the number of replicas that you specified in your Helm release matches the ones that you've got inside Kubernetes. They run their set of feature tests or whatever tests they want for that environment. And then they go on the journey again, but this time they commit and push with studge or stage. And then we essentially test, rinse, and repeat all the way to production. So now what this gives us is we've decoupled CI and CD. We're getting the developers to focus on the thing that is important to them, which is the testing and confidence that they need to move that microservice version between environments. we're going to handle the deployment, and we're going to handle the scenario where it doesn't work. That's our kind of boundary, right? So in terms of CI, we've greatly simplified the pipelines now. There's no more Helm upgrade. There's no more kube configs. There's no more like cluster-wide kube configs that sit inside Concourse. The kube config that is used by Concourse is simply read-only, very tightly scoped. You can read the deployment and you can read the replica set, and that's it. That's all you can do. So that's kind of application-based changes, but what about Kubernetes YAML changes? So here we don't need Concourse, right? We can leverage a SaaS provider. So in this scenario, we're leveraging Circle CI. So we will run a number of checks. So the first one that we run is we run a deprecation check. So we use conf test for this. If any of you are not familiar with what conf test is, you specify or declare a set of policies that you want. You execute those policies against your configuration, and it will either pass or fail. So it's essentially a warning or a deny, and you make a decision on what you want to do with that. So for us, what we wanted to do is make sure that we're ahead of the deprecation curve, right? I don't want to go and tell all the developers that they need to change their Helm chart because we decided to upgrade from 1.14 to 1.16, right? That's the best example because in 1.16, they deprecated a load of API versions and it would have caused us a heap of pain. So now with these policies, these deprecation policies that we're testing against, we're looking at 120 or 121. So we're already ahead of the curve. And what that's going to be able to do is it's going to make our cluster rebuilds when we upgrade our version of Kubernetes much more easy, because we know that we're not using deprecated APIs and we're constantly ahead of the curve. So we run these checks against our Helm charts and also all of our YAML files, all of our Helm releases. So we make sure that we're specifying the right API version for Helm releases, all of the deployments, literally everything. The next one is kubeval. So what kubeval does is it lints your Kubernetes manifest or your resources against the upstream JSON schemas. So we're running 1.17. We run kubeval against the 1.17 JSON schema in strict mode. What this means is it makes sure that we don't deploy things to Kubernetes that shouldn't be there, right? In the past, if you go back, when everyone was looking after their own individual Helm charts inside their application repositories, we would get in this sticky situation whereby people that shouldn't need to know about Kubernetes, and they're not Kubernetes experts, they're application developers, and that's the field that they're in, are deploying things to Kube that aren't actually right, that get rejected by the JSON schema or the schema that we're currently running. So what we're doing now is we're shifting left. We're making sure that that doesn't happen, and we'll block at the CI level. So we've removed this from a developer's concern. We'll handle this for them. They just become consumers, and we know that they can't add things to the Kubernetes manifest declaration that are invalid. And then the final and most important one for us is HRval. So what HRval does is, if you remember what the Helm release looked like, it had the chart version and it had the values that sit underneath it. What HRval does is it pulls down the chart version, untars it, and then essentially does a Helm template. And if you don't know what a Helm template is, it renders out the manifests with your value overrides, and then runs kubeval against them. So now not only are we testing just the individual discrete Helm charts themselves, we're also discreetly linting how those Helm charts are consumed in Helm releases. And what that gives us is even more confidence than the step above, because now we're validating against exactly what you're trying to deploy to Kube. So we run this as part of all of our environments. So you make a single commit, and your commit is to dev. We'll run HRval against all the Helm releases in dev. If they're not all successful, we will reject, and you have to keep going around this iterative loop until you get a pass. Then we merge, and by the time Flux has picked it up, we've got a high level of confidence that it's actually going to work, and it's most likely going to be an application problem at that point. So those are the changes. So then how do we kind of bring this cluster up? So again, like we said before, we start in Amazon, and we're going to use Terraform for that. From a Kubernetes perspective, we leverage something called Bootkube. So Bootkube is a self-hosted control plane. It's what tools like Tectonic by CoreOS used to use. And what that allows us to be able to do is define what we mean by a vanilla cluster. So what does the cluster look like the first time it comes up? So if you're ahead of my thought process here, the one thing that we need at this point is a Flux instance, right? So we do a Terraform apply, the Kubernetes cluster comes up, the first Flux instance is going to come up, and then it's going to start to reconcile. So the first Flux instance comes up as part of Bootkube, and the first place it attaches itself is Kubernetes resources, right? And because that's where all of the heavy lifting and all of the large majority of the scaffolding and utilities that are needed get deployed from. So let's take a look at what that Flux instance actually looks like. So from Flux to reconcile, you've got to pass it a URL, a branch, and a path. So if you look here, we've got this consistency. We've got the path and we've got the tag. So this 3-letter prefix now is becoming really important, right? We've got it on the Helm releases, but we've also got it on the way that Flux is reconciled. So for us to be able to deploy a new production cluster, you just change dev to prod, and we're going to reconcile everything back up. As part of the first reconciliation loop inside Kubernetes resources, we deploy another set of Flux instances. So we need a Flux that comes up that's going to reconcile K8's releases Mettle, because that's going to drop in our Mettle workloads. We then deploy another Flux instance that's going to look after Kubernetes secrets, and that's going to deploy all our secrets. And then we have another Flux for Kafka topics, and that's going to deploy all of our topics to Kafka. So an interesting point here is, Steve, how did you used to create Kafka topics in the old platform? So I kid you not, a gentleman in our team used to go onto the Kafka nodes and actually manually create the Kafka topics in each individual environment, right? So we've got a nice Snowflake servers now because we've actually SSH'd into them and we're executing random commands. No consistency there. You know, he types a 2 instead of a 20 or a 20 instead of a 2. All these environments look different. So now we've got a repository that contains all of our Kafka topics. We've got strict CI against them to make sure that you can't do anything silly, and we get that consistency. And then we just have Flux reconciling them. Inside the cluster, we have our custom Kafka topic operator that looks for these new topics, interfaces and interacts with Kafka, and then tells us when it's completed. So we've now got each individual component now declaratively declared in Git. They've all got this directory structure. So we've got these, these environments. Each of these individual discrete repositories have the dev, staging, and production. And we've now got a very simplistic pattern for us to be able to bring up these clusters. So we've got this ephemeral cluster. We know that we can tear it down and we can bring it back up because we've got the way that we reconcile the Flux instances. We've got this clear ownership. We've got clear repository boundaries. We've got different code owners for different areas of the platform itself. So the final bit is this reliable and consistent bit. And that's normally the hardest bit to kind of get and nail. So how do we make sure that it's reliable? Well, one of the tools that we use is kubectl, right? We deploy this into every single environment. For those of you who don't know what this does, it randomly deletes a pod in your Kubernetes cluster every 5 minutes, right? And you're saying, Steve, you're running this in production. You're literally mad. What are you doing? Running this taught us a lot of lessons about the way that our applications are actually being deployed and managed, right? And how they actually interact with each other. So classic comment, oh, Steve, I can't do something. It must be a platform problem. Well, no, actually, Chaos Cube just deleted one of your pods and your application couldn't handle it, right? And we're constantly running this all the time, and we're learning more and more lessons about how the whole platform works. So we run this in all of our environments. And then what we do in terms of a test bed is we ramp up this and make it a bit more aggressive, right? So we're practicing outages, and the way we practice outages is rather than 5 minutes, we turn it down to 30 seconds, right? And it's constantly deleting random pods within the cluster. And we're seeing if our observability is good enough. Is our alerting good enough? Are those like 99 Grafana dashboards that we have actually all valuable, or do we just need 10 of them, right? I've seen it before. People spend so much time creating Grafana dashboards, they only ever go to 2 of them when there's an incident, and all the other ones are just basically noise and have to be kept up to date because we think that they're important. The other one that we do is we repave. So by repave, I mean that we stand down the cluster completely and we tear it and we stand it back up again, right? We do this about every 60 days. We want to turn this and tune this down to every 30 days. And that just gives us even more confidence, right? That the thing that we've built works. And when we have an incident, a terrible incident, like as an example, a whole region goes down, how quickly can we reconcile back and get ourselves back online? So what is this whole journey and this kind of GitOps mantra and like thinking about things as pull-based and not allowing pushes to be made and changes to be made manually or being executed by the tooling? I think this speaks for itself. So the number of production deploys that we did last month, 218. The number of successful deploys that we did last month, 218. Right, so every deploy to production was successful. And I think the reason behind that is because now we've got consistency. The way that we deploy between environments is the same. The developers are solely focused on the thing that gives this success, right, which is the CI portion of this delivery. Right, they focus on those test suites. How quickly can they make them? How concise can they make them? How accurate can they make them? And the deployment is taken out of their hands somewhat. The most important thing for me about this GitOps journey is trust, right? We've got trust from the organization in terms of, you know, our mean time to recovery when there's an incident. We've got trust from the developers. You know, they can essentially deploy microservices now without us getting in their way. So a prime example is we started a new product team. Within 2 weeks, they had 15 microservices deployed to production. I literally didn't talk to them once. I only talked to them once via a PR when they created the namespace for them to deploy into. Because we've templatized it nicely, you get all the resource quotas so they can't go and do something silly like ask for 16 gig of memory for one of their pods. So now we've got this differentiation, right? We've got this contract, which is the Helm Release. You know, we have a way of being able to interface with them. We leverage PRs and code ownership of our repositories, so that if you're going to make a change that's going to affect all of the environments at the same time, then yeah, you probably want one of us to look at it. If you're making a change to dev, you just get the engineers to look through that. Platform team are focusing on making the platform better. Developers are working on innovating and adding and giving new features to our customers, and essentially everybody wins, right? We've got out their way. There's no more tug of war. It's essentially turned into hug ops, and we all hug each other because everything's just nicely working. So every journey is never complete. So what's the kind of next step, Steve, in your kind of journey? So for us, it's about progressive delivery. So how do we make sure that when we upgrade from version 1 to version 2 of our microservice, that it's either 100% success or 100% incident, right? You don't really want to be running a bank whereby at the change of one microservice, you actually can't get any of your data about all of your transactions that you've ever made. That's just terrifies us. As well as that, we want a way of being able to drip feed customers from, say, a Kubernetes version 117 to a 118. So we're looking at multi-mesh clusters. So in dev, we'll have 2 or 3 clusters. We'll mesh them all together, and then we'll slowly drip feed customers from old cluster to new cluster and slowly but surely move them across. Right now, it's big bang. It's kind of what I would call a Hail Mary move. It either works and all of our customers get success, or we have a horrendous incident and I go back to being Mark Zuckerberg and have to explain myself. That's not really a great look either. So in summary, I think there's 3 main takeaways for me. It's about, the first one is get this consistent naming convention. So this 3-letter character prefix that we have, it runs throughout everything. It runs in infrastructure, runs in our way that we structure our repositories, runs in the way that we label all of our resources for that existing specific manifest. And it allows us to be able to build this tooling around monitoring, around alerting, around deployment pipelines, so that we get this consistency. I think when you shift your mind from thinking pull-based rather than push-based, you start to actually unravel a load of stuff that would probably scare you if you actually sat down and thought about it, right? Think about concourse and the keys to the kingdom and how powerful that machine actually is if some rogue employee went crazy. They're one kube config away from kubectl delete everything, and we've got a major incident. And then I think the third and final point is that failure will happen and you've got to be ready for it, right? So kube chaos, prime example, repaving, a prime example. Practice these things. Don't become firefighters when an incident happens. Constantly learn from these mistakes. So I'm going to leave this slide here for a little while, maybe like 30 seconds or so. These are some useful links that go into a bit more information about the tooling that we use. So at the top is specifically tooling. So we use Customize, Flux, and the Helm operator. And then at the bottom is a couple of repositories. Deprecates shows what we use for deprecations. The GitOps with Customize is an example repo of a look of how we set it up at Mettle, so you get a bit more understanding of how this actually works under the covers. And then the last one is the Medium link, where I've blogged in a lot more depth about all of this from a technical standpoint. So I want to leave you with kind of one slide. So how easily can we make changes to all of our clusters, right? At any one point, we could have 10 clusters, or we could have 12 clusters, or we could go back down to 8. So we made one change. If you look here inside Customize, we're making it to the modules directory. The modules directory is consumed by all other directories or all other environments. We make this change, we commit it to master, and all environments get upgraded to the latest version of Nginx. So no more having to drip feed it through all the environments. We could do that if we wanted to. But this is just an example of now the power that we get from leveraging both Customize and GitOps. We drive all these changes through Git. We've got this PR process as the interface for people to disagree or agree to the changes. We merge. 20 to 30 seconds later, we have what we declared. And I think that's a really powerful mechanism. That's all for me. I'll open it up to questions.
Awesome. Thank you, Steve. Great talk. We only have one question, but I do have a lot of questions on my list. The question is regarding compliance. When Flux applies changes to the cluster before committing to Git, you effectively have a new version running before the audit trail shows. Say the new version crashes the node it's running on, which eventually turns the release into an incident. You miss the audit trail in Git. Right, so it's when Flux commits back, and if something goes wrong, you sort of miss the audit trail.
Yeah, so the important thing to note here is Flux doesn't wait, right? It again, with Kubernetes, it's desired state. So the intention is there. When you do a kubectl apply, you don't wait for it to return back to you. You commit your desired state, and then Kubernetes tries to reconcile that desired state. So what Flux is doing is it executes the kubectl apply, writes back the changes to Git. It doesn't have this. It doesn't have the discrete understanding of knowing all of the changes and the way that your application is made up. It's essentially looking at the desired state, seeing that there's a change, applying it to Kube, and then going back to Git, telling it that it's made that change. That change may not be successful, right? It's the same way that if you do a kubectl apply, it may not be successful as well. It may come back to you and return back to the screen, but when you actually look under the covers, it could be a total mess. And if there's so many Helm releases and so many resources that if Flux waited for every single change, you would never get in a situation whereby your reconcile loop was tight enough that you'd actually be able to deploy changes. It would just constantly keep sitting there. And there'd be a load of configuration and understanding that you'd need to wed into Flux that says, okay, well, when you apply this Helm release, you need to be looking at X, Y, and Z, or you need to be looking at A, B, and C.
Thanks. Oh, and we actually got a question in the YouTube chat. So just a reminder, if you have any questions for Steve, please post them in the YouTube chat or in the Tech Talks channel. And we got a question from Rasmus. Is Kafka shared across environments, clusters, or spun up per cluster?
So every environment has its own distinct Kafka cluster. So for us, the Amazon account is the boundary. So right now, there's a dev account and it runs the dev clusters, and Kafka kind of sits at the bottom of that, if you think about it. So you can have two clusters that are both dev, but one's 117 and one's 118, and they're still consuming from that Kafka that kind of sits underneath.
Then as a follow-up, do you have other dependencies for a cluster like databases running on VMs? In that case, how are those handled?
So yeah, we do have other dependencies. So again, when we were talking about different routes, different Terraform routes, we have Terraform routes for data. So we have TFN data platform, and that is the databases or the RDS clusters or the S3 buckets that are required to be there for the platform to work. So a prime example for us is an S3 bucket that we need for Thanos to ship metrics to a centralized location. So it's all of the databases and kind of data components are driven through Terraform. And it comes back to lifecycle, right? So the cluster is the thing that's ephemeral. So we delete the cluster and we know that we're not going to lose any of its dependencies because they are in totally different Terraform routes.
Awesome. So I have a question regarding Terraform and how do you apply the Terraform modules and all that? Is that also running in some kind of reconciliation loop, or are you running something like Run Atlantis, or how are you doing this?
So right now, the decision that we made is to focus heavily on the self-service portion from a queue perspective and give the developers the ability to be able to specify changes that they want to make from an infrastructure perspective. Those infrastructure changes are currently applied manually from a platform engineer's laptop. The next phase in kind of the GitOps journey is how do we move that away from people's laptops and move it to something else. But we have quite a lot of discrete kind of steps that happen as part of an apply. So a prime example is when we apply to production, we actually create a tag in Git for that production change. But we also have a version checker as well, which makes sure that you can't apply a hash in production that hasn't already been applied to dev and staging. So there's a lot of kind of custom logic that we have, and moving that into some kind of pipeline needs to be kind of thought about.
Cool, thanks. So do Henrik or Rasmus, do you have any questions for Steve? Did you come up with something during this talk?
Yeah, so Henrik actually posted one about, and I also consider it, why do you use the total or the full Git share instead of just using Git tags, for example? Is there a reason for this?
Yeah, so for us, for the commit share is because the pipeline that is being executed is against a given commit hash, right? You're making a commit. That is essentially your differentiator. It's the difference between the previous commit and your current commit. So using that commit hash allows us to be able to look at any microservice that's currently running in production, go to that commit hash, pull down the repository, check out that exact commit hash, and that is the exact change that is currently running in that environment. So for us, it's about how can we take something that's very simplistic, which is the image tag, and pull it all the way back to the commit, and that ties the two things together. The coding or the feature change all the way through CI and CD all the way into production.
Couldn't you do the same with a tag?
Say that again, sorry?
Couldn't you do the same with a tag, a Git tag?
You could, but do we want to tag every single time we do, like, you know, a one-line code change as an example? There'll be a lot of tags there for that. And we're not, a tag is a discrete component, right, or of execution. So when we merge to master, it's on its journey to production. If it doesn't make its way to production, we really probably shouldn't be tagging it. It's not really a release. It's just a release candidate. So what we see is all of the commits that we make are release candidates. And depending upon the image tag depends upon how far through that journey to production it actually got.
Cool. We got another question from the YouTube chat. How are you handling logs? Are they centralized?
How are we handling logs? So each individual platform or cluster or environment has an Elasticsearch running in there with a kind of Kibana on top. Elasticsearch, we're using the managed one, mainly because our platform team is relatively small and managing Elasticsearch can become quite a bit of a nightmare. We run Kibana inside the cluster with SSO in front, and we just kind of leverage that. We have an archiving strategy that archives that data off to S3, and then we have another component that will allow us to be able to kind of read that cold storage and use S3 as the kind of medium to be able to pull that back. But for us, a lot of our changes or a lot of our kind of log usage is more real time. We don't really go back. So we keep, I think it's 14 days in actual Elasticsearch, and then we archive the rest off, because we very rarely need to go back further than 14 days to get the information that we're looking for.
I have another question.
Yeah, sure.
So you said you didn't want to use a CI system because it has access to everything, and if you hack that, then you can do a lot of fun stuff.
Mm-hmm.
How do you secure your Git repositories? Because if that's your source of truth, then all I need is access to the Git repository, I guess.
Absolutely. So a number of ways. So as part of the Terraform execution, one of the Terraform routes is Terraform key pairs, and we use Terraform to interact with GitHub. We create a key pair. That key pair is stored in two places. One is an S3 bucket in the security account that security can access, and the other one is actually being deployed to the Git repository itself. And then we have a way of being able to reconcile that. So if we needed to, we could reapply the Terraform key pairs route, recreate our key pairs for development as an example. That will change them in GitHub, and also correspondingly, we have a way of being able to change those inside the cluster as well. And in terms of who can do what with regards to the repositories, again, it's all down to the code owners. So the GitHub repository is specified as code. We've got specific code owners that are in there. We've got how many approvals that you need to be able to make certain changes to certain directories. It's all kind of, those kind of top level things are driven from code in terms of Terraform. And then it's up to the engineers that are the ones that are responsible for those given repositories to manage those kind of PRs being merged. So a prime example is secrets is a little bit more sensitive. So there's more, you need more approvers. You also need more than one approver from the security team. And normally that, in terms of a block, that's probably the biggest blocker in terms of functionality releases, because that's the most sensitive repository, because it holds, a lot of sensitive information. Whereas a Helm release, less dangerous. It's just going to deploy the workload.
Is this ensuring the rogue developer better than before? How?
Yeah, absolutely right. Because the rogue developer before, the prime place they're going to go is Concourse. They know they can do a kubectl apply. I pull a random YAML file off the internet. I kubectl apply from Concourse. It goes to the cluster. Now what I've got to do is bypass and be able to somehow get to master, because we only track the master branch in Flux for all of our repositories. So you've got to get past the PR process, and you've either got to get 2 approvers. So you've got to have 2 rogue employees, or in some scenarios, you've got to have 3 rogue employees, and they've all got to be in different teams. So the likelihood that you're going to be able to bypass this and get something into our environments that you shouldn't is like greatly being reduced now. So
the security is not in GitOps, it's in the reviews and approvers.
It's in the reviews. We also have some things that are running internally in the cluster that will reject. So with regards to conf test essentially runs off of policies, and we use something called Gatekeeper, which is Open Policy Agent, and that's doing the check. Once the YAML file hits the API server, it can reject there as well. And we've also got a number of other kind of security-based tools that run inside Kube to look for changes. So Falco is an example, looking for kind of erroneous kind of execution of specific processes within given containers. But yeah, I think that's probably a separate talk in itself, because we could go into quite a lot of depth about that.
We have 1 minute left. So just to round this off a bit with one last question, I'm kind of curious to hear how easy is it for developers to actually create. So I want to create a new service that needs an S3 bucket, and I want to expose this to the application, to the mobile app. How many sort of, and I also have a secret because I'm integrating probably with some external, but how many sort of touch points do I need to set up configuration in that sense?
So you would touch 3 repos. So you touch Terraform, the Terraform repository because you need an S3 bucket. You'd touch the secrets repository because you want to declare a secret, and then there's a conversation between you and the security engineers to allow that to be able to be deployed. And then the K8 releases Mettle repository for you to actually deploy your workload with a Helm release. So 3 touch points.
Cool. So we are out of time. I'll just take a minute to say thank you for being here today, Steve. It was a really great talk, and I hope everyone who followed on the live stream enjoyed it as much as I did. As mentioned, we will be back next Thursday with GitOps and the GitOps toolkit. So following a bit along these lines that Steve just talked a bit about. And yeah, if I'm not sure if you are still in the Slack, but I see people tagging you. So if you have any more questions, I'm sure we can forward those to you.
Yeah, sure.
Somehow.
Sure. Feel free to reach out to me, use the Twitter handle or send me an email, whatever. I'm happy to help. We've got, like we said before, right? We've got a pattern that works now. It's a case of helping other people. Yeah, and the Twitter handle is right here and the email. So that's plenty of ways to get in touch. But other than that, thank you for today, and see you next time. No problem. Thanks, everyone.